All right, this is page 3 of the Chapter 6 notes. And what we're looking at now are the common oxidation states. That means the charge of the elements in the periodic table. And we can just look at the periodic table and predict how many electrons are going to be gained or lost. So let's still first look at the A groups, and these are also called the representative elements. And these are all the tall columns. So these are the tall columns. Now the representative elements behave like we expect them to do. So their behavior is representative of what's supposed to happen. So let's take a look at this first family right here. This is the alkali metals, if you remember that. All of these will tend to lose one electron. And so this whole column tends to take on a positive 1 charge. This next column, the alkaline earth metals, all tend to take on an oxidation state of 2+. Now we're going to skip way over here. These are the transition metals, and we're going to go to the next representative element column, and that's headed by boron. Boron is a nonmetal, so nonmetals do not take on charges. However, aluminum is a metal, and aluminum takes on a +3. So aluminum is a +3. Now, notice we've gone across tall column, tall column, tall column, and it's 1, 2, 3. The next column that we're going to look at is the carbon column here. These do not take on a charge. These form molecular compounds. They're not going to be gaining or losing electrons, so we don't even worry about these for now. These take on no charge. However, once we get over here to the nitride family, now let's complete this column, these all take on a -3 charge. We're going down to the staircase. The oxygen family takes on a -2 charge, and the fluoride family takes on a -1 charge. Now here we're at the noble gases again. These do not gain or lose an electron, so we have an oxidation state of 0. Now what I want you to look at is we've got kind of a pattern here. We're looking at just the tall columns. We go 1, 2, +3. Then we've got no charge. Then it's -3, -2, -1. It's kind of like carbon forms, the carbon family forms kind of this backwards mirror. So you go up, 1, 2, 3, and then you go down, -3, -2, -1. Now these other ones under here, the transition metals, here the charges vary. And they can vary anywhere between 1 and 7. And these also vary down here. So these are the B groups where the charges vary. And they can have more than one common oxidation state. So the B columns, B groups are your short columns. And they have more than one common oxidation state. Now, we indicate the oxidation state or the charge by using a Roman numeral. So you're going to have to remember what your Roman numerals are, and you have to be able to count up to 7. So let's do this. We've got 1, we've got 2, we have 3, 4 is IV, 5 is just V, 7 is V1, 6 is V1, that's 6, V1, and 7 is V2. Okay, so that's 7. So 1, 2, 3, 4, 5, 6, 7. You need to memorize these. So what does this mean? We've got iron 2. What this means is that iron has a 2+ charge, or oxidation state. This always is going to be a positive number because cations are always going to form from metals. Iron 3 is going to be Fe3+. So the Roman numeral 3 indicates it has a charge of +3. Now there are some exceptions for the metals that are down here that you need to memorize. Silver is always going to be just 1+. And if it's just 1, you can just indicate it by a positive. Zinc is always going to be 2+. And cadmium is also always going to be 2+. So you need to remember that your aluminum is always going to be +3, silver is +1, zinc +2, cadmium +2. You just need to memorize that. Just notice that was misspelled up there. The others, you can tell by where they are in the periodic table. These are always going to take on a +1. These are +2. Aluminum is +3. And then these all form anions here. So you just look at the periodic table to determine what's going on. Okay, let's scroll down the page. And we're going to talk about something called polyatomic ions. Polyatomic ions are a group of atoms that act as a unit. In other words, they stay stuck together. And they carry a charge. So, for example, this right here, this formula, means we have 1 sulfur, 4 oxygens, and the whole thing has taken on a -2 charge. Now, this thing is called sulfate. And sulfate, looks like we've got a sulfur in the middle. And it has 4 oxygens attached to it, kind of, sort of looks like a flower type thing. And each one of those is an oxygen. And the whole thing has a -2 charge. Phosphite is another one. Phosphite has a phosphorus in the middle, and then it has 3 oxygen atoms attached off of the phosphorus. And the whole thing carries a -3 charge. A couple of others, you've got cyanide, so that's cyanide. And that looks like a carbon atom stuck to a nitrogen atom. So they're bonded together, they're not going to come apart. And that has a 1- charge. And then another one would be nitrate, NO3-. And that one's got a nitrogen in the middle. And it's got 3 oxygens around it. And the whole thing has a -1 charge.